Okay. Basically, what are they asking me to do with that long left-hand side? Combine it into 1. All right, we just want to combine it into 1. So that's going to be log base 2 of 39 to the 5th plus log base 2 of 39 to the 3rd minus log base 2 of 39 squared. Okay, so I just pulled my coefficients up as exponents. Now, they want me to put it together into 1 logarithm. So I'm going to keep 1 log base 2. That'd be 39 to the 5th times 39 to the 3rd divided by, 39 squared. Okay, so let's simplify that, because if I look over here at the right-hand side, they just want 1 log 2 and a 39. Okay, so if I put that together, 39 to the 5th times 39 to the 3rd is really 39 to what power? 8th over 39 to the 2nd. And then 39 to the 8th over 39 to the 2nd is really 39 to the 6th. So A is equal to 6. Okay. All righty then. Let's do the same thing with number 2. All right. Using my properties, throwing things together. This time, though, it wants me to find a coefficient. So it wants me to get me to 1 ln of m with a number in the front. Okay. So let's just work through it. I've got ln of m plus m to the 1/2. So I'd be 1/2. Actually, let's leave it like that. ln m to the 1/2 plus ln. What power is m going to be to in that last one? -1. Good. Okay, to the -1. Now, what we want to do is we're going to get that into a single logarithm. Everything's being multiplied. So it's going to give me ln m to the 1st times m to the 1/2 times m to the -1. All right. What am I going to do with all of those m's and their exponents? Add them all up. It's going to give me m to what power? The 1/2. So if I bring that back out as a coefficient, I have 1/2 ln of m, and so k is equal to 1/2. Okay. Just using those properties. Okay. Well, all right. Well, today we're going to shift gears. Yesterday we were just kind of rewriting, looking at logarithmic functions. Today we're going to solve equations. All right, and inequalities. We're going to talk about inverses. And we're going to do lots of examples. Okay, it's basically what it comes down to today. The strategies are pretty straightforward. It's your basic solving of equations, but there's a few little extra somethings in there just for fun, to keep life interesting. All right. Anytime we want to solve an exponential equation, there are typically 2 types. Okay. The first one is if I have a common base, or I can rewrite with a common base. So what that means is I want a single exponential function on each side. If I need to, I'll rewrite with a common base. All right, so if one side's 2 and one side's 8, 8 could be written as 2 to the 3rd. Okay. And then if the bases are equal, bless you, my exponents are equal. So it's just going to make it a little bit quicker for me to solve this equation. Okay, so we want a single exponential function on each side. If they don't have a common base, we're going to rewrite it with a common base. And if my bases are equal, my exponents are equal. So we can drop the bases and just work with the exponents, which is nice. Some basic strategy there. Okay. We're going to put all of your equation solving prowess to work today. All right. So let's look at the first one. All right. Do I have one exponential expression on each side? Yes. Are the bases the same? Yes. Thank you, Jesus. So 5x minus 1 is equal to 2x plus 7. And we should all be able to solve that equation in our sleep. Okay. 3x would equal 8. X would equal 8/3. Okay. Those are my favorite. All right. They're the easiest. Okay. Probably the one you'll see the least. Okay. Just being honest. All right. Let's jump to the next one. Okay. So right now I only see one exponential expression, all right, but it has a base of 9. The other side's 81. Could we do anything to make it better for ourselves? Yeah, 81's 9 squared. Okay. And so now I've got two exponential expressions. So 4y minus 26 equals 2. All right, again, much nicer to solve. Okay. Don't think when you're solving just because you get a fraction that it's wrong. Okay. A lot of people think that fractions are not the devil. All right. There are more fractions in the world than there are whole numbers. Just saying. Okay. So don't be afraid of a fraction. Now let's get to the good stuff. All right. Let's get to the good stuff. Look at C. All right. Well, the first thing I notice is I have 3 exponential expressions in there. All right. Could I do some rewriting so that I could get 1 base of 12 on the left? I've already got 1 base of 12 on the right. All right. What's your first suggestion? Yeah, 1 over 12 is the same as 12 to the negative 1. Okay. Times 12 to the x squared equals 12 to the 2x plus 3. Okay, now with that negative 1, all right, what's going to happen with negative 1 and 4x plus 3? Yeah, they're going to multiply, all right? So when you have a power to a power, you'd multiply. So this is the same as 12 to the negative 4x minus 3 times 12 to the x squared equals 12 to the 2x plus 3. Okay, now in doing that, how can I get that left-hand side to 1 base of 12? What would I do to its exponents? I'd add them. So this is 12 to the x squared minus 4x minus 3 equals 12 to the 2x plus 3.
Why is it 13?
It's 13. I don't know why I keep saying 3. Do y'all know I did that when I actually worked this problem out in my notes? Because I kept going back going, why did I not get the right answer? Couldn't see it. Okay. All right, so now that we've got a single base of 12, we're just going to let our exponents be equal to each other. This is a quadratic equation. How do we solve those? Yeah, move it all to one side. Okay, I'm going to move it all to one side, so I'm going to have x squared minus 6x minus 16 equals 0. Now how could we solve? Yeah, let's factor if we can. All right, I like it when they give me ones that factor nice. There are times you'll have to use the quadratic formula, but not on this one. All right, so it'd be x minus 8, x plus 2. What are my two things that x is equal to? 8 and negative 2. Okay, so this is using your properties of exponents. It's using what you know about quadratic equations. Like, it's just a good problem. It's got a lot of good juicy stuff in it. Okay, spicy, spicy. Why so spicy? Okay. Rebecca says that all the time, by the way. She can't take anything with any kind of heat. I'm like, I'm not sure how you're mine. Okay. All right, let's look at D. 512, 1 over 64, 1 over 8. Any guesses on what the common base is? 8. Okay, it's 8. All right, so let's walk through it. All right, 512 is going to be 8 to what power? The third. So that would be 8 to the 3y squared. Okay. 1 over 64. Okay. What would that be? 8 to the negative 2. So that would be 8 to the negative 6y. All right. And then 1 over 8 would be 8 to the negative 1. So 8 to the negative 5y squared. Okay. Let's get a single exponential on each side. I would add those exponents, so negative 6y minus 5y squared. Okay, so just distributing those negatives or those extra powers. Finish it out for me. We can still factor. It's just a GCF, right? What's y going to equal? Yep, 0 and negative 3/4. Bless you, bless you. She's allergic to exponential equations over there. It happens. Okay. Questions? Type 1. Yes. 2y equal to 0, and I solve for y. Take each term, just like we did x minus 8 and x plus 2. To get 8 and negative 2, I took 2y equal to 0 divided by 2, so y was 0. And I took 4y plus 3, set it equal to 0. 4y equals negative 3, y equals negative 3/4. Zero product property. Okay. Yep, with just this one. All right, here we go, type 2. Exponential equations. All right. This time we're going to use a logarithm. All right. And so there are actually two schools of thought on this. Both work the same and give you the same answer. Okay. Isolate the exponential expression. And then rewrite it in log form. Okay. So isolate the exponential expression, rewrite it in log form. Okay. Sometimes you're not going to be able to do that. Okay. Sometimes you're just not going to be able to do that. So our options, if we can get it to one exponential expression on each side, then we can take the log of each side, or the ln. We're going to actually do that to one here in a minute. Okay. So if we have one exponential expression on each side, we can take the log or the ln of each side. All right. Because in solving equations, we want to, what we do to one side, we want to do to the other, right? Maintain that sense of equality, right? But let's start simple, right? Let's start simple. Okay. So if I wanted to isolate my exponential expression, e to the x, who needs to move away from e to the x? The 3 and the negative 4. Who gets to go first? The 3. Okay. So we're going to start by moving the 3. So I have negative 10 equals negative 4 e to the x. Okay. Now what would I do to get e to the x by itself? Divide by 4. So I would have e to the x equals 10 divided by 4, or what would that be, 5/2? Okay. Okay. So divide by negative 4. All right, the negatives would both go away, reduces to 5/2. All right. Now, if I'm going to rewrite that in log form, here's why we do that. What do logarithms equal? In the expression, what do logarithms equal in the exponential expression? The exponent, okay? So if I want to write this, a log with a base of e is an ln. It's going to equal x, and what's going to go inside my logarithm? 5/2. That's an exact answer. You can leave it that way. Okay? If it's on a calculator section, you can type it in and get a decimal approximation. All right? But that is an exact answer. Okay? So move your 3, divide by your -4, isolate your exponential expression. Let's look at B. Okay? All right, let's look at B. We got a 1/3 there. Not the devil, all right, but I would rather use a whole number if I could. Okay? So if I rewrite that 1/3, what would my base become? 3. What would my exponent become? -1 times 2x minus 5, or -2x plus 5. Okay? Now, the main reason I did that was to see, could I rewrite 120 with a base of 3? Well, the answer is no. Okay? But it always gives me an option, all right, if I can possibly rewrite. Okay? Do I have my exponential expression isolated? Okay, let's put it in log form. What's the base of my logarithm going to be? Log base 3. What's going to go inside next to it? 120. And it's going to equal -2x plus 5. The thing to remember is that log 3 of 120 is a number. Okay, I don't know what number it is, but it's a number. All right, it's a decimal value of some kind. So if I wanted to get x by itself, what would I have to do? Subtract 5 from that whole expression, okay? It doesn't subtract from the 120. It subtracts from the whole expression. So that's why I put it in a parenthesis, so that it's protected. Okay? Equals a -2x. We're talking about an exact answer right here. All right? And then how would I get x by itself? Divide by -2. And so x is going to equal log base 3 of 120 minus 5 all over -2. You can simplify that if you want to, but that's an exact answer. Okay? And that's all you have to do. If it's on a calculator section, then you can get a decimal approximation. Right? But that's an exact answer. Okay. So now let's get to the good ones. Okay, let's get to the good ones. These are going to take a little bit of time, all right, to work through. There's a lot going on here. When I look at the first one, I'll look at C. I've got 2 to the x plus 5 equals 3 to the x minus 2. First thing I notice is I cannot rewrite 3 with a base of 2 or 2 with a base of 3. So setting the exponents equal is not an option. Nor can I get one exponential expression because I can't rewrite them to combine them. All right. This is where that taking the log of both sides comes in. All right. Because as long as I do the same thing to each side, it's all legal. All right. So just so I don't have to write as much, I'm going to use an ln. All right. So I'm just going to take the ln of 2 to the x plus 5, set it equal to the ln of 3 to the x minus 2. I did nothing illegal because I did it to both sides. Okay, I took a logarithm, right? Now, we're going to use properties of logarithms here, okay? What do the properties say I can do with those exponents? I can bring them out in front, so I'm going to do that. So I have x plus 5 times the ln of 2 equals x minus 2 times the ln of 3. Okay? Now, you're probably thinking, I don't think we helped ourselves there. All right, well, sort of we did, okay? Because what happens, ln of 2 is a number, right? And what do I do when I have a number next to a parenthesis and I'm solving an equation? I don't divide. I multiply, I distribute, okay? I distribute, let's distribute, okay? So this is going to give me x ln of 2 plus 5 ln of 2. Okay, I'm distributing that ln of 2. It's a number. Okay, it's like it's a, 1.43. Right? I'm going to do the same thing on the next side. X ln of 3 minus 2 ln of 3. Okay. Now, like we did when we did inverses, I want everything with an x on one side and everything that doesn't have an x on the other. Okay? So who's going to move to the left? It's already, I don't want to move that one to the left. Let's move the x term. Okay? So I'm going to subtract it. So that would give me x ln of 2 minus x ln of 3. I'm also going to move that 5 ln of 2 because it didn't have an x. I'm going to move it over. Okay, so that gives me negative 5 ln of 2 minus 2 ln of 3. So I just reorganized. Okay, I switched sides. If I'm solving for x, do I have an x in each one of those on that left-hand side? Yeah, pull it out. ln of 2 minus ln of 3 equals negative 5 ln of 2 minus 2 ln of 3. Now, how do you get x by itself? Divide. Because that expression in parentheses, that's a number. Okay? It's a number. It's written weird, but it's a number. All right? If you type on your calculator ln of 2 minus ln of 3, it's a number. Okay? So my x value is going to equal, I'm going to write up here because I'm out of space, negative 5 ln of 2 minus 2 ln of 3 over ln of 2 minus ln of 3. It's an exact number. I have no idea what the decimal approximation is because I didn't bother to type it in. Okay? That's an exact answer. I divided both sides by ln of 2 minus ln of 3. All right? It's just division. All right, take a minute, digest that.
Do people actually use this, or is it just an out?
No, we'll actually use it in calculus. So we can integrate. All right. Hi, friend. Do we want to go to Kuwait tomorrow?
Yeah. You're not gonna play, right?
We're not going to play.
We went to the English side. We got 3 people. Everybody else was going to play.
Or just not.
Are you two? Stop. Golly, I don't teach kindergarten. Bless it. I know, you're just the second, it's always the second one that gets called, but Reese has been doing it all freaking day, and I've tried not to backhand him, but it's been hard. All right. Okay. God bless. All right. Thanks. What did I sign up for? 10 o'clock?
10:05.
10:05. I'm right on the board, so don't forget. All right. Questions about all of that good stuff? Because there was a lot there. It's a lot of math. All right? But it is algebra in its purest form.
I see that on the test. I don't remember.
Yes, you will.
If I see that on the test, I'm gonna draw a smiley face.
Well, you got to just try. That's all we ask.
Is there? I think.
Yes, ma'am.
Sorry. I think the biggest thing is we need to practice on it.
You do. You'll need to practice.
Is there a practice?
I think so.
What's the reason you chose Ellen?
I could have chosen log. I just wanted to write one less letter, so I chose LN.
So you can use log or Ellen?
Yes, they're basically equivalent.
So if you choose log, you don't have to have a base.
No, you can just put log. Doesn't matter as long as we do the same thing to each side. I could have chosen log base 7 as long as I do the same thing to both sides. Okay, good question.
If I get 90% of the multiple choice questions right and don't get any of the other ones right, will I still pass the test?
No. You have to make, on the AP, I don't know, I got to go back and calculate that on the pre-cal test, but on the calculus, if you get a perfect score on multiple choice, which rarely happens, you can make a 3. But I don't think that's true on the pre-cal test. I'll have to go back and look.
Oh,
Okay. All right.
Is the pre-cal test, is it, like,
Is it what?
is it calculated in like?
No.
trying to get a
No,
good grade.
totally separate. It's totally separate.
So it's not like the ELC?
No.
No, it's not.
No. Mm-mm. It's totally separate. Scores will come back till July.
Basically like a base point, like grade.
I'm already going to
Or like if you pass it. Oh, if you pass it, you get college credit.
Mm-hmm. Depends on your school and what they accept.
I've been hearing some rumors that this is not real. That college does not take it.
Take pre-cal?
No, the scores, AP college scores. Well, I just saw it on TikTok.
Oh. I will say, if you take this test and you pass, and you take calculus and pass, they will give you the higher credit. So you would get, the math credit would be the calculus credit, and you would get an elective credit for pre-cal, because that would keep you from taking like just a crazy elective you have to take to fill your schedule. So you still get credit. Does that make sense? It just, yeah, depends on your school. All right, let's look at this one. I really love this one. Because when I look at this, it really scares me a little bit, because there's e's and then there's negative exponents, and there's just a lot of crap going on, okay? So I like to start this one by rewriting for just a second, okay? And I typically don't do that, but I am this time. So I've got e to the x plus 2 over, I'm going to drop that down and make it positive, okay? Equals 3. And I want to show you why I'm doing that, okay, in just a second. Because I don't want a negative exponent in this problem, okay? Because if I've already got e to the x's, then maybe I can do something with that, okay? Now, because there's a fraction in this problem, how do we clear fractions? We multiply everything by that denominator. So I'm going to multiply both sides by e to the x, okay? So I'm just going to distribute and multiply both sides, all right? When I do that, what's e to the x times e to the x? Oh, tricky, tricky. What do you do with your exponents when you multiply? Add them. So this is e to the 2x, okay? Plus, it's going to cancel out with that middle term. I'll get a 2, and it equals 3 e to the x, okay? So I cleared the denominator. I rewrote it with a positive exponent, and then I cleared the denominator. All right? Now, I don't know what to do next, but maybe if I could set it equal to 0, something fun might happen. Okay? So I'm going to pull that over. I get e to the 2x minus 3e to the x plus 2 is equal to 0. Okay? Now, Emil's face. That's why I love y'all. Okay. How many terms is that? 3. Which is a trinomial. Okay? And most trinomials I can factor into 2 parentheses. Okay? So let's see if we can do that. It's a trinomial. All right? The first term in each parenthesis has to match. So if I got e to the 2x, what did I really multiply? E to the x and e to the x. Okay? Because it's a trinomial, it's got to multiply to 2 and add to negative 3 for that middle term. So what would I get? Minus 2 and minus 1. Okay? So using the zero product property, all right, e to the x would equal 2. E to the x would equal 1, okay? So just like when we factored in those other ones that were quadratic, all right, x was the opposite, but this is an e to the x. Now, here's where we use that exponential solving. Rewrite it as a logarithm, okay? If I have a base of e, that would give me the natural log of 2 is equal to x, okay? I just rewrote it. The second one, the natural log of what number? 1 would equal x. Now, can I simplify either one of those logarithms? Okay. The first one, do I know e to what power gives me 2? No. But that second one, e to what power, gives me 1? 0. So my solutions are 0 and ln of 2. Okay? That is an exponential equation in quadratic form. All right? An exponential equation in quadratic form. So take a second, dig through that. What you... Okay? Good stuff. Huh? An exponential equation in quadratic form. Oh yeah, I love that. Okay? Exponential equation in quadratic
When you
form.
look up there, it's like in those movies when the whole chalkboard is just.
Yes.
Why do we have to use?
Wait, is this the one that we're talking like?
I love equations. It's a puzzle. It's a big puzzle.
It's like a number. It's like a code.
Yeah, he's like pi. 2.71. Okay. All right. So that's all of our exponential equation methods. They are varied. Okay. And I jumped quickly. All right. I jumped quickly. All right. But let's talk about the log methods. The good news is they're very similar. Okay. They're very similar. We're just going to go the opposite direction. All right. So when we solve a logarithmic equation, two types. All right. You want a single log on each side. With no coefficients. Okay, a single log on each side. Just like exponents. If the bases are equal, the stuff inside is equal. Okay. Now, log equations are different in one respect, okay? The stuff inside of a logarithm is very specific, has to be positive, okay? It has to be positive. So we always have to check for extraneous solutions. That's not the end of the world, okay? Okay, the inside stuff has to be positive. It has to be greater than 0. We always plug it back into the original equation. Okay, back into the original.
So e to the x equals like -1, that would be an extraneous solution.
That would be correct.
What did you just say?
No negatives inside. Okay, doesn't mean you can't have a negative number. If I put it inside to something that's squared, is it still okay? Yes. Okay, so that's why you have to double check it. You can't just mark it out because it's negative, nor can you just assume every positive number works. Okay, you have to check them. All right, so let's do a couple. Okay, so let's look at the first one. So I've got ln of k squared minus 4k equals the ln of k plus 14. Do I have a single log on each side? Yeah, okay, we do. So I can, and do the bases match? Yeah, they do. So all I have here is k squared minus 4k equals k plus 14. Okay. What next? Yeah, move everything to one side. It's quadratic, right? So that would give me k squared minus 5k minus 14 equal to 0. There you go. Let's factor. Okay. Multiply to negative 14, add to negative 5. Negative 7, positive 2. And so what does k equal? 7 and negative 2. Okay. Now, let's check them. Right? I put 7 in for inside the logarithm. 7 squared minus 4 times 7. Positive or negative? Positive. And then 7 plus 14. 7's good. All right. Let's put -2 in there. -2 squared, positive. -4 times -2, positive. I've got two positive numbers right there. -2 plus 14. It's positive, okay? -2 plus 14 is positive. These both work. Nothing's extra, okay? They both work, all right? If we plug them in, they both work. I don't get a negative number inside my logarithm, okay? You just have to check them. Now, let's look at B. B requires a little extra work, all right? Because there's a lot going on here, okay? There's a lot going on here. If I could get a single ln on each side, then I might be able to make it happen, okay? A little easier. So on the first side, or the left, all I can really do is bring that exponent up. So I have a plus 1 to the second, right? On the other side, I'm going to do what's in parentheses first. So what's it asking me to do with the 80 and the 5? It's subtraction, so when I combine it, what would I do? Divide. So this would be 80 divided by 5. Well, how much is that? 16. Okay. All right. So again, I got to get rid of that coefficient in order to set my sides equal. So I have ln a plus 1 squared equals the ln of 16 to the 3/2. Right? So now I've got an ln on each side. We can drop the ln. I've got a plus 1 to the second equals 16 to the 3/2. Right? Now, we got to remember how to do 16 to the 3/2. It's a number. Okay? That's the square root of 16. Then I'm going to cube it. Okay? That's what it means. It's the square root of 16, and then we're going to cube it. All right? So what's the square root of 16? And what's 4 cubed? 64. Okay? All righty. Now, how am I going to solve that equation? Take the square root of both sides. When I take the square root, how many solutions do I get? Plus or minus, I get 2. Okay, anytime you take a square root, you get 2 solutions. Okay. So my solutions are -1 plus 8 and -1 minus 8. Okay, so let's look at that. That would give me a 7 and a -9. Okay. We have to go back and check them in the original equation, right? I only have to check one side. There's only one side with an A in it, okay? So 7 plus 1, we good? Good. Yep. -9 plus 1, not good. There's only one solution, and it's 7. Okay?
What do you plug into again?
Inside the logarithm.
And then you just do it.
It has to be positive.
You just put it in your calculator.
Nope, you put it in your brain. You don't have to do all that stuff. You're just looking at the inside stuff has to be positive.
Oh, okay.
Okay, just the inside stuff. Okay?
Outside good. Okay.
Mm-hmm. Alrighty, let's do the second side. Okay? So there's 4 different strategies, 2 for each kind. Okay? All right. Isolate your logarithm. Be sure it's a single log. Rewrite in exponential form. Always check for extraneous solutions for log equations. Okay. So let's take a look at the first one. I want to isolate that log base 5. Who needs to move? The 2. Okay. If I pull that 2 over, that gives me log base 5 of 2x minus 1 is equal to 2. Okay. So now we have a single logarithm that I want to write in exponential form. Okay. What would I do?
5 squared equals 2x.
5 squared equals 2x minus 1. Okay. How much is 5 squared? 25. And then we solve for x. So 2x would equal 26. Okay. X is 13. Check it. All right, because it is possible you could solve and get an extraneous solution. If there's only one thing and it doesn't work, what would you say? No solutions.
Where'd you get the 5 squared from?
I rewrote it in exponential form. Base to a power equals what's inside. Base is a base. Logarithms equal exponents. And gives me 2x minus 1. Okay. All right, let's look at B. Is that 5 inside the logarithm? No. So I can get it out of the bottom of that fraction by doing what? Y'all are so smart. Okay. So the ln of 2x, 2 minus x, is going to equal 5. Okay. Just multiply. All right. Do you have a single logarithm? What's its base? E. When it's ln, the base is e. Okay. Logarithms equal exponents, so my exponent of e is going to be 5. And it equals my junk inside. All right. Can we solve for x? Sure enough. All right. I'm going to pull the x to the left and the e to the 5th over to the right, just so that I have positive things. All right. If I pull the x over and the e to the 5th over, x is going to equal 2 minus e to the 5th. That's an exact answer. That would be it. If it was calculator, then yes, you would type it in and get a decimal. Otherwise, you're going to leave it just like that.
Where do you find A in your calculator?
It's right next. It's above ln, second ln.
Okay. All right.
Okay. Yes, ma'am.
How do we check for extraneous solutions of that?
Okay. So that was where you would plug it into your calculator to get a numerical value. All right. E to the 5th. All right. If you think about that, it's going to give us some kind of a negative number. All right. So let's go in and look. Does it work?
So you'd only find that solution if it's in a calculator.
Yeah. Okay. We'd have to plug it in and see if it would work.
So if it was a non-calculator question,
We would just leave it. They wouldn't leave you one like that to check. It would be one you'd be able to check. Okay. All right. Hey, he didn't have a can top today, though. It was a bottle. He wasn't popping tags back there, popping tabs. All right, let's look at this one. Okay, let's look at this one. We have got log base 2 of c squared minus log base 2, 3c minus 5 equals 2. All right. I got multiple logarithms here. I need to condense it to a single log. Because it's subtraction, how do we fix subtraction? Division. You got it. So I've got log base 2 of c squared over 3c minus 5 equals 2. All right. Now I have a single logarithm. Okay. So we're going to write it in exponential form. What's my base? To what power? And it equals c squared over 3c minus 5. Okay. 2 squared is the same thing as 4. So I've got c squared over 3c minus 5 equals 4. All right. How would I go about solving that equation? Yep, multiply that denominator. So I have c squared is going to equal 12c minus 20. It's quadratic. Yeah, let's pull some things back around. Minus 12c plus 20 equals 0. All right. Let's think about factors on that one. Okay, multiply to 20, add to negative 12. Minus 10, minus 2. And so we find our solutions as 10 and 2. Okay, let's check them. All right. The first one says I need to square what I found. So 10 squared, positive or negative? Positive. 3 times 10, take away 5.
Positive.
Positive. Okay,
10 work.
10 works. All right, let's try the 2. 2 squared, positive. 3 times 2 minus 5. Positive. They both work. All right. Let's do this one. Okay. So log of x minus 2 equals log of x minus 7, right? I'm going to rearrange the log of x minus 7 and the minus 2 so that I can pull that number to one side and my logs to all to one side. Okay, so I have log of x minus log of x minus 7. It's going to equal a positive 2. So just rearranged my order, moving things from one side to the next. What you think you might want to do next?
Divide.
Okay, we're going to write it as one log and division. So log of x over x minus 7 equals 2. Now I got a single log and a value. Let's write it in exponent form. What's my base? 10. When I can't see it, it's 10. All right. When it's ln, it's e. Okay. So 10 to the second equals x over x minus 7. Okay. Which gives me 100. Right. What you gonna do next? Yep. Yeah, we're gonna multiply. So I get x equals 100x minus 700. All right, we didn't get a quadratic this time. Yay. Okay. If I pull the 100 over, that's going to give me negative 99x equals a negative 700. We divide by a negative 99. We get 700 over 99. I have no idea if that reduces or not. I'm just going to leave it. Okay. Now, when we check that, we have to think for just a second. 700 divided by 99. If it was divided by 100, it would definitely be 7. All right. So it's a little more than 7. So is that going to cause a negative number when I plug it in up there? No. Okay. So I'm good. All right. All right. I think your brains have endured as much as they can endure. All right. So here's what we're going to do. All right. Tomorrow we will finish this lesson. I am going to go ahead and give you the practice, though. Just don't do the ones about inverses or inequalities. Okay. Do the ones with equations. Then, all right, that means that after the quiz on Monday, I'm going to have to teach that next lesson. All right. But it's easy. It's just modeling on your calculator, which is not hard. Okay. Regression, that kind of thing. All right. So it's an easy lesson for us to throw in 15, 20 minutes on Monday. All right. Your quiz Monday will go section 7 through 12. So it will be what we did yesterday, not today. Okay. All right. So let me jump to that page. Hang on just one second. All right. So let me write all this down. Okay. Because you got a lot to look at. Okay. So there are 3 worksheets just because you need to see a good variety of problems. All right. On A, I would do 2, 6, 8, 12, 14, 17, 19, 20.
We have nothing on A, like, it's blank.
Okay, let me load the other one.
And on B,
Okay,
and like, and like, the top version of C.
okay. 14, 17, 18, I'll go change them. And 19. And C, 3, 6, 8, 10, 12, and 13. All right? Now, don't do anything with yet, okay? So no inequalities, you're not ready for that yet. Okay? And nothing on the inverses. Okay. Your quiz Monday will cover sections 7 through 12. Okay? Also on Monday, I will teach 213. Okay? So, but tomorrow we will finish this. All right? So we will finish 212 tomorrow. Nope. This is 213. And I'll cover 214 on Monday. Okay? Nope, 215. And 215 is something you've never seen before. I had never seen it before, but it's not hard. It's a weird looking piece of graph paper. It's kind of cool once you get used to it. Okay? All right.